Hello everyone, and welcome to the Choropleth Maps lecture. In this lecture, we're going to go over how to use Python and Plotly to create Choropleth maps, which will allow us to plot out information either on a global scale or on a nationwide scale. Let's go ahead and jump to the Jupyter Notebook to get started. Alright, here I am at the Jupyter Notebook. This Jupyter Notebook is called Choropleth Maps, and you can find it under Python for Data Visualization under the Geographical Plotting folder. And you should start a new notebook there or work inside of this notebook in order to access the CSV data we're going to be working with. Again, all the code we're going to be typing up is a reference here, and also you should note that there's references as far as explanations. Choropleth plots can be really difficult at first, especially the syntax used for Plotly, so you'll always want to keep this notebook as a reference for things. And what we're going to do is just go out and explain the code in this notebook, see some simple examples at first, using just nationwide scale plots. Then we're going to see some real data, do a larger plot on nationwide scale, and then we're going to go ahead and see the world scale, so we can actually plot onto countries. Alright, let's go ahead and start a new Jupyter Notebook. Alright, here I am at a Jupyter Notebook. I'm going to go ahead and start off with some imports. First, I'm going to import plotly.plotly as py. And then I'm going to say, in order to do all of this offline, I will say from plotly.offline imports download underscore plotly.js, and I'm just using tab to autocomplete this. So I just type init, and then it'll autocomplete to init underscore notebook mode, and then plot and iplot. So 4 functions to complete, and you can just copy and paste this code from the notebook if you want. And then I'm also going to then call init underscore notebook mode and pass in connected is equal to true. And that way we can see everything inside the Jupyter Notebook. And there's a link in your lecture notebook for other options to use Plotly offline. Okay, again, like I mentioned, Plotly's mapping can be a bit hard to get used to. So there's a copy of a cheat sheet as well as a link to it in the Jupyter Notebook, and it looks something like this. So you can see basic charts with Plotly, how to use them, and if you scroll down, you can later on see actual maps in the cheat sheets here. This is kind of the format we're going to be following. Let's go ahead and jump back to the Jupyter Notebook. First thing we need to do is begin to build our data dictionary, and the easiest way to do this is using the dict method. So you can actually just cast a dictionary with dict. So we're going to be using that method to cast a list into a dictionary. And the first thing we're going to do is start off with our data. So you have your data, and it's going to be a dictionary. And we're going to have the key type be Choropleth. And then we're going to have locations. And locations is a list of states. And it's the abbreviation for the states in our case, since we're doing this just on a nationwide scale. So we'll go ahead and say AZ, CA, and NY. You can go ahead and put in any postcode abbreviations you want there. Then we're going to say location mode. And in this case, we're going to put in USA-states. And this lets Plotly know that we're doing this on a United States level. And there's various location mode, and you can go ahead and check out the links in the Jupyter Notebook to get the documentation on the various location modes you can provide. Then we're going to go ahead and set the color scale to be equal to Portland, which is just a color scale. And we can also do other things such as greens or grays, and we'll mix this up and see how it works later on. For right now, we'll just choose Portland. And then what we're going to go ahead and do is pass in another key, text, and text is a list of what hovers over each of the locations. So I'm just going to put some basic stuff here. We'll go ahead and say text 1, text 2, and then text 3. And then Z is going to be equal to your actual values that are going to be shown in a color scale. We'll go ahead and just set these to 1, 2, and 3. And I'll put them in as floats. And then finally, we pass in a color bar argument. And this is actually a dictionary with the key title, and then you would just pass in, you would pass in whatever you want the color bar title to be. So as a very generic one, I'll say color bar title goes here. All right, so that's what data looks like. And if we just take a look at data, it's going to be a dictionary. For whatever reason, the Plotly documentation likes to use this sort of dictionary casting call instead of just building it out as a dictionary. This kind of saves you time for typing in all these quotes and not having to make all these strings for keys. So we'll just go ahead and keep in line with the documentation and use this sort of notation. Next, what we want to do is create a layout object or variable. And layout is going to go ahead and be a nested dictionary. And we just pass in geo is equal to, and then we set the scope to be USA. And then what we're going to go ahead and use is the go.figure. And in order to do that, we're going to need to import something else. We'll have to say import plotly.graph_objs as go. And I'm going to go ahead and just put this up at the top with the other imports and run that. Okay, so now that that's imported, we can say go.figure and set data, and this is kind of the weird part, equal to in brackets, so as the item of a list, data, which is kind of strange because it's already a dictionary, but you pass it in as a dictionary inside of a list. And then you just say layout is going to be equal to layout. We don't technically need to actually pass in data equals and layout equals. We could just pass in data and layout, but let's go ahead and just keep it this way. And we'll set this whole thing equal to Choromap. And then what we do is say iplot Choromap. And we should see the plot here. And here we have Arizona, California, and New York highlighted with the Portland color chart chosen here. And we can go ahead and change it to one of the predefined strings shown in your notebook. For instance, we can go ahead and change this to jet, see what changes happen there, run everything again, and here we have now the jet color scheme. Or you can do other things such as greens is another one you can choose. Run that, and now everything is in greens, with New York being the very light green over here. Let me go ahead and just break down everything we just did, because the formatting can be kind of confusing, and it really just takes time. You usually don't actually memorize this. You'll have to reference examples from the documentation or from the cheat sheet. But the basic idea is we have our imports, we initialize notebook mode, and then we have two main objects, a data object and a layout object. And I can call these just my variables, my data variable and my layout variable. I'm going to pass those into the go.figure function, and then I'm going to pass that thing into iplot. If I just pass it into plot, what will happen is this will open a new tab as an HTML file, and you can go ahead and save this HTML file or export it, or you can download it as a PNG. All right, but let's go ahead and go back to lecture here. In our data object, we have a couple of arguments. We have type, which clarifies what type of geographical plot we're doing. In this case, we're focusing right now on just choropleths. Then you have locations. Locations is an array or a list of those actual state abbreviation codes. Then you specify location mode, and in this case, since we're working with USA, we're going to say USA-states. And this can go down to county level. You can go ahead and reference the documentation that's linked in the Jupyter Notebook for more information on that. Then you have the text, and the text is an array or a list of the text that lines up for each of the locations. So for example, go ahead and change this to Arizona, change this one to Cali, and change this one to New York. And if we run this again, you'll notice that in plot, let me go ahead and specify it as iplot so we see it inside the Jupyter Notebook. You'll notice when I say iplot, the text value says Cali, Arizona, and New York. So that means that this text just has to be in the same index sequence as the locations, and it's going to match up. Then the Z is whatever value you want to represent as a color. So for instance, Cali was value 2, Arizona was value 1, and New York was value 3. Later on, we'll see with real data how we can actually use this to kind of indicate certain levels by state. But here, that's what the color bar is relating to. And we can see that the title of the color bar goes here, just is a title for this color bar. And you can choose the color scale with whatever string you want that's mentioned in that Jupyter notebook. Again, for this type of plotting, you'll really have to reference either the documentation or the Jupyter notebook because the formatting is really kind of bizarre here, but that's the way Plotly works. Then you have a layout variable and a nested dictionary object where you just specify geo and the scope to be USA, since it's going to be a USA states Choropleth. And then you pass the whole thing into go.figure and you say iplot choromap, and you see this here. Now let's go ahead and show an example with some real data, as well as some other options we can add to the dictionaries in data and layout. So we'll go ahead and build on the knowledge we already have. I'm going to go ahead and scroll down here. And I'm going to say df is equal to pd.readcsv. And there's a CSV file here called 2011 US _agri _exports. And these are just agricultural exports by state. And let me go ahead and import pandas in order to read that in. And then we'll check out the head of this data frame. So in this data frame, I have a code, the actual state name, category, in this case they're all states, total exports, and then things such as beef, pork, poultry, dairy, etc. So what these states are exporting for agricultural products. All right, so let's go ahead and get started by creating our data variable and our layout variable. My data variable is going to have that dictionary casting, and we'll go ahead and say type is equal to Choropleth, and then we pass in a color scale argument. In this case, I'm going to pass in the string capital Y, capital I, capital O, lowercase r, capital R, lowercase d. And this is kind of a yellow, orange, red. And then next, I'm going to say locations. And remember our locations, if we scroll back up here, was just the list of state codes. And our locations mode is also here. Now, we actually have in our data frame, if we look at this, a code column. So I'm just going to pass in df code. And the next is going to be our location mode, and we'll set that equal to USA-states. And we also want to specify what we're going to say for Z. And Z is going to be what the color bar is actually representing. In this case, let's go ahead and say the total exports. So we have total exports as a column there, and that's going to be our Z value. We also have text, and that's just going to be text that lines up. And if you scroll all the way to the right, there's kind of conveniently placed text column here. Usually you'll probably have to build your own text column, but since this is just an example, we already have text for you. We'll go ahead and pass in text there. And then we also want to pass in a color bar. I'm going to say color bar is equal to, and this is where you have that dictionary, where you just have the title of the color bar. In this case, let's go ahead and say millions USD, because that's what the actual total exports represents. It's the number in millions of US dollars. Now we're going to go ahead and add one more argument to this, and it's going to be the marker equals. And this is kind of a weird argument because it's a set of nested dictionaries, but this basically is going to define a marker that we're going to show once we show the plot. And you're going to say cast a dictionary, line as a key equals, and then another dictionary casting call, and you say color is equal to, and Plotly can accept RGB color as a weird string format. You say RGB, and then in parentheses you pass in your RGB values. So let's go ahead and just say 255 for all three of these, for red, green, and blue. And then I'm also going to specify inside of this inner dictionary that the width is equal to 2. And we'll see later on how that marker actually comes into an effect. And then finally, I want to make sure that we have a comma here. So we have the next key, and we close it off. All right, that's my data dictionary. Now we're going to have our layout dictionary. I'm going to say layout is equal to, have my dictionary casting call. I can set the title of the actual plot. And let's go ahead and say this is 2011 U.S. Agriculture Exports by State. Then I'm going to say geo is equal to, and I'm going to pass in a dictionary here. We have scope is equal to USA, and I'm going to pass in 2 additional arguments inside of this dictionary. Show lakes is equal to true, and that basically just says show the actual lakes on the map. And then you can choose lake color. And I'm going to pass in an RGB code using Plotly's notation for RGB codes, which is just a string RGB, and then in parentheses the colors or the values you want. So we're going to say 85, 173, 240, and I grabbed these from the internet because they basically make a nice blue for the lakes. And that's going to be our layout dictionary. So we just take a look at that. We kind of have this weird nested dictionary structure, but that's the way Plotly takes it. Then finally, we can say Choromap2 is equal to go.figure. Data equals, and we pass in that data dictionary into a list, and then we just say layout equals layout. And then finally we call iplot on Choromap2. And here we have now 2011 U.S. Agricultural Exports by State. And notice as we hover over, we get to see all that text, those values, California. We also see that the lakes are blue, meaning that show lakes and the color of the lakes worked out correctly. We have our color scale, we have our title, millions USD, and we also see that there's kind of this spacing between the states themselves. That is what that marker represented. So if we go back here under data, we had this marker. So we set a line with a color and then a width. So if we increase this width of the line by, let's say, double, and let's go ahead and change the color to be something like 12, 12, 12, so it's really obvious. I'll run this again, and then notice how this map is going to change as far as these borders. All right, so now I have very thick black borders because I changed those RGB values. And you can do that just by following this kind of formula here, saying dictionary line, and then dictionary again. You choose the color and the width of the dictionary. We'll go ahead and just set this back to something like 1. And if I run this again, we can see our plot. All right, that's how you can create Choropleth plots on a US national scale using Plotly. Now, I should note it is pretty confusing as far as the syntax and trying to remember what order everything goes into. My best advice to give you is to reference the Jupyter Notebook and to reference the documentation links in the Jupyter Notebook. More often than not, you'll just have to essentially copy and paste and then fill in the relevant code for your particular data set. It's not easy, but that's the way you have to do it. And this is just by nature, geographical plotting is pretty tricky because it can come in so many formats that they try to make it vague so you can pass in as many possible locations or location modes, but that just leads to kind of weird syntax structure. That's the nature of this game of geographical plotting as far as trying to use Plotly as a Python library for geographical plotting. But you can see after all that hard work, you do get something that is quite nice to show other people. All right, coming up in the next lecture, we'll show how to do this on a global scale with global Choropleth plots. Thanks everyone, and I'll see you at the next lecture.